These notes are over section 6.4, behavior of light. So we were talking about the electromagnetic spectrum. So now we're going to be kind of focused on the visible light. But we're going to be talking about the behaviors. So it's going to be very similar to what we saw with the behaviors of mechanical waves. They're going to have very similar interactions with objects. Okay, so first off, without light, nothing would be visible. So if you're in a dark room, it's very, very hard to see the objects around you. You know that the objects are there, but you can't make out their shape or their color and things like that. Even in dim light, you can still maybe see the shape of objects, but the colors are not true to what they would be if you had available light to you. Okay, so materials can be three things. They can either be transparent, translucent, or opaque. So transparent allows the most light to pass through. So examples of transparent materials are like glass, water, especially like just thin levels of water. Okay, so if I had a transparent object covering this image of the apple, I'm still able to see the apple clearly. I'm able to see all the colors and the detail because the light is allowed to pass through. So if it was like a piece of glass over this picture, I'm able to see through it because it's transparent. Translucent allows some light, but then it also scatters some of the light, which causes the image to be a bit more fuzzy. Okay, so examples of translucent materials would be like frosted glass and like some of the plastics. You're able to see through those objects, but not as clearly. So it might have, like the image might be distorted where you can't really tell what the image is. You can tell that there's something there, or it's not going to be as brightly colored. You're not going to see the true colors of that object. So if you've ever looked through like frosted glass, it's kind of hard to see through it. You can kind of see shadows, but you can't see the object clearly. Okay, so here if I had like a piece of plastic over the image of the apple, I can still see that it's an apple, but the colors are not as bright. I don't see the detail. It's a bit fuzzy. Okay, and then lastly we have opaque. So opaque objects absorb or reflect the light. So you can't see through these objects. So examples of opaque objects are like an apple, a table, well not a glass table, but like a wooden table, or a cat. Okay, so all these objects you're not able to see through, so we would describe them as opaque. Okay, so if I had a piece of white cardboard over my picture of the apple, I'm not able to see through to the apple because the opaque cardboard is not allowing the light from the apple to shine through for me to see that image. So as far as interactions of light, they are very similar to what we saw with mechanical waves. Okay, so first we have reflection. So with light, we can have two different types of reflection. So we can have regular reflection or diffuse reflection. So regular reflection, light has a smooth surface or hits a smooth surface, and so we get a very clear image that looks exactly like the original object. Okay, so if we had like a clear pond that doesn't have any ripples, it's very, very still, we're going to see the image reflected back very crisply and looks just like the mountains above them. Okay, same thing with a regular mirror. When we look into a mirror, we're seeing a regular reflection. It shows exactly what you look like in real life. Okay, a diffuse reflection, the light hits a rough surface and it causes a blurred image. So here we have ripples in the water, and it causes us not able to see the image clearly reflected. We see that there's lights. We can kind of tell what colors are in the above boardwalk to us, but we can't see exactly what's happening reflected clearly back at us. Okay, and so this is a diffuse reflection. So if we had a mirror that was warped, okay, we would see a diffuse reflection. So even though it might not be blurred, it might have warped the way that we look, and then that would be considered a diffuse reflection and not a regular reflection. For interactions of light continued, we have refraction. So we talked about refraction whenever we talked about mechanical waves as well, but this is when light travels at different speeds through different mediums. So remember we saw like the picture of the pencil in a glass of water, and so the light at the top of the pencil being reflected back to us is going to be traveling at a different speed than if it's traveling through the water, and so that's why it looks like kind of the pencil is broken, but really what's happening is that light is just traveling at different speeds through the different mediums. Okay, same thing here with this image. So we have the light traveling through the air. Okay, it's being shot. It's basically a laser. It's being shot forward, and then as it hits this block, this prism, we'll just say it's made of plastic, it's going to slow down and cause the direction of the laser to bend. Okay, so it bends here, so then it's going in a straight line again, but then as it exits the prism, it's going to start going straight again, okay, because it's going through air again, so it's going to go straight. So even though it doesn't bounce back down here, but it is going parallel to the light here, so it kind of traveled a bit, okay, so it's moving at different speeds, and that is refraction. So light is unique in that it can be polarized because light has two planes, okay? So light has a wave that goes in the horizontal direction and in the vertical direction, so it is polarized. So polar just means two, and it means like opposite, so two opposites. Like our North Pole and South Pole, they are two parts to the opposite end of our Earth. Okay, so polarizing filters can be used to block certain waves, and so this can be helpful if you are like a fisherman or if you've ever tried on like polarized sunglasses. They are especially they are their special polar filters that help to block out glares. So with the polarized sunglasses, fishermen use them because when you're fishing, there can be a glare coming off of the water surface. And so the specialized filter polarized glasses have these like slits basically that only allow a certain wave to come through as far as the light. So it might have these vertical ones that only allow the vertical wave to pass through. It blocks the horizontal wave, which is causing the glare. Scattering is just when light is redirected as it passes through a medium. So I kind of talked about scattering whenever I talked about translucent objects. So like frosted glass, it scatters light, and that's what kind of gives it the appearance of it being all white or frosted, because it's scattering the light. Okay, our sky and sunsets are actually colored due to scattering. Okay, so our sky is blue because what happens is when the light rays enter our atmosphere, they're going to encounter like the particles that make up our air and atmosphere, and they kind of bounce around. And so it actually bounces the blue lights. When we go through the spectrum, like the rainbow of colors, okay, blue is on the smaller end, and so they're able to be bounced around more easily than like the red ones. Okay, and so because of that, the blue gets scattered in our atmosphere, and so that's the color that is apparent to us in the sky. Okay, the red and green and yellows, they all pass through fairly easily. Okay, when the sun sets, because the sun light waves are coming in at an angle to our atmosphere, it actually passes through more of the atmosphere than whenever the sun is directly overhead. And so because of that, the particles are able to be more scattered. Okay, and so because there's so many that it runs into, it actually starts to scatter those orange and yellow and red colors, which causes the colors of the sunset.